We are on the first lesson of Chapter 5, which is angle relationships. First, we're going to classify angles, then we'll find angle measures, and then we'll do a real-world application. If you haven't learned this before, it would be really good to go through the types of angles. When I teach these, I really like to start with the right angle because we know this angle really well. I mean, for example, this is the floor of your house. This would be a wall of your house. It is a perfectly perpendicular lines, meaning they perfectly cross each other. So this would be a 90-degree angle, a right angle as it's called. Usually it's designated by this little square here. So whenever you see that, assume that this is a right angle. Anything smaller than a right angle then, if we use this line here, anything smaller than a right angle would be an acute angle. And that's what we see over here. So acute angles measure less than 90 degrees. Anything greater than a 90-degree angle, which would be going this way then, would be an obtuse angle. And that means it's more than 90 degrees, but we also see that it's less than 180 degrees because 180 degrees is just a straight angle, which is another word for a line. There is really no angle here. It's just a straight line. A couple other terms we need to know would be complementary angles and supplementary angles. Here I see two angles. This one is 60 degrees. This one is 30 degrees. Complementary angles would add up together to create a right angle. So we see that 30 plus 60 is 90. These would be complementary angles. Same thing with supplementary angles. These add up to something else. See, a straight angle is 180 degrees, meaning a straight line is 180. I see a straight line right here, except with a little gap, obviously. But that would make me believe that these are supplementary angles. This is 110 degrees, FED, and then CBA would be 70 degrees. Put these next to each other, and they're going to form a straight line when they're together, meaning that they're supplementary. They supplement each other into a straight line. So we're asked to use the diagram to name each figure here. We need to find two acute angles. And when we name angles, we have to make the vertex the middle letter. So here the E is usually going to be the vertex. That's the middle dot in each angle. So E will always be the second letter. Whether I say DEC or CED doesn't matter as much. All that matters is I have that E in the middle. So if I find two acute angles, that's two that are less than 90 degrees. So I see that AED is a acute angle. So we do AED. And then my other one would be, we're going to go CEB. CEB. Notice I have E in the middle both times because E is the middle of the angle. Now we need two obtuse angles. And here I don't see any obtuse angles listed, but remember if I add two angles together, like this 60 degrees and this 90 degrees, that would be more than 90 degrees there. So I could do AE with the middle one and then C, like pretending this line isn't here. That would be a 150 degree angle, AEC. So that's what we'll say, AEC. And then the other one I could do would be the 90 with the 30, because that would be 120 degrees. So I would go BED. So that would be an obtuse angle at 120 degrees. Now we need a pair of complementary angles. So these would be two angles that would add up to 90 degrees. So even though they're not next to each other, I see that CEB, which is 30 degrees, and DEA, which is 60, would add up to 90. So I would write that in. AED, which is this left one here, with BEC, these ones together would create a complement, or 90 degrees. Then we have a pair of supplementary angles. There's a couple different ways you could do this. You could add this 30-degree angle, CEB, with the 150 degrees that CEA makes, or I could do the 60-degree angle, DEA, with the 120-degree angle, DEB, that these two make. So what I'm going to do is I'm going to choose the one with the 60 by itself and then these two together. So I'd say angle AED, which is AED, and then that one paired with DEB. And then together, 60 plus 120 equals 180. That would be a pair of supplementary angles. Now we need to find angle measures by using this diagram here. It says if angle 2 is 75 degrees, so we'll make angle 2 75 degrees, find angle 3. And at first this might seem like an impossible task. Like, how am I supposed to know what this is if it doesn't tell me any other numbers? But we do see that here is a line running along here. So that means that angle 2 and angle 3 are supplementary. And when they're supplementary, as we've seen before, they add up to 180 degrees. So I could use this information knowing that 2 and 3 together equal 180. So I could do 180 equals angle 2 plus angle 3. And since angle 2 is 75, I know that 180 equals 75 plus angle 3. So I'm going to subtract 75 from both sides. And that would give me my answer. So that means that angle 3 is 105 degrees. And now that I found angle 3, I can also find angle 4. So I see that this is a line here, meaning that it's 180 degrees. Therefore, angle 4 is supplementary to angle 3. Supplementary is 180 degrees, so that equals angle 3 plus angle 4. I can just do A maybe. So A3 plus A4. So then I'll do A3, angle 3 is 105. 180 equals 105 plus A4. Then we can subtract 105 from both sides. So therefore, 180 minus 105 is 75. So angle 4 equals 75 degrees. And you'll notice that'll be exactly the same thing as this one over here at angle 2. These are called vertical angles, meaning they're opposite sides of each other. Whenever you have two crisscrossing lines like that, vertical angles are going to be made. So 75 is over here. I could have just put 75 over here and saved us a lot of time, but I wanted to show you how to do that. Since this is vertical to this, therefore angle 1 would also be 105. So vertical angles are nice and easy to remember. They're right across from each other. Let's do a real-world application then. An artist is designing a section of stained glass window. Based on the diagram, what should be the measurement of ECF, angle ECF? So here's ECF. What would that be? And we had to use a couple of the things that we've learned so far. And I want to use these lines here to use the supplementary method. So here I see that BCA is supplementary to DCA because there's this line right here. They both make this line. So therefore, ACD or DCA would be 180 minus 32. So DCA equals 180 minus 32, which would be 148. So I'm going to write that in. So that's this angle right here. I also see that this ACD is supplementary to DCE because they create this line now. So what I could do is I could say that DCE, angle DCE, is 180 minus 148. 180 minus 148 equals 32. So DCE equals 32. So I'm going to write 32 in here. Now that I've worked my way around, I could solve ECF. I see that DCF forms a right angle. See that box right here? So that means that DCF is 90 degrees, and part of that already by DCE is 32. These are complementary angles. So I know that ECF would be 90 degrees minus this 32 degrees that DCE is. So we'll say ECF equals 90 degrees, which is this 90-degree angle here, minus 32 degrees. 90 minus 32 would be 58. So ECF equals 58 degrees.